All right, the first trend that we're going to be talking about is the atomic radius. But the problem with the atomic radius is that it's actually really hard to define where one atom ends and where one begins. And the reason why is because it's kind of like electrons exist in this cloud-like state. So if you were to tell me and look up at a cloud and I asked you the question of, could you please tell me where one cloud ends and one begins? You couldn't exactly pinpoint where one ended and where one began because they kind of blend and mesh together. Same thing occurs with an atom. So what they ended up doing is they take half the distance between the two nuclei or nucleus of a diatomic molecule. I think it's easiest to understand by a visual. So what they do is they find two nuclei, okay, which are the nucleus, and what they do is they measure that distance and then they just divide it by 2. And that is defined as the atomic radius of whatever element you are talking about. So in this case, we would be talking about hydrogen. So once they've defined that, what you need to know is how to identify which elements are going to have the largest size as far as radius goes and which ones are going to have the smallest. So going down a family, we are going to be referencing those influences that we talked about in the previous video. What happens is that the radius gets larger. And this makes just perfect sense when you think about it. You have a nucleus, and each time you go down a row, you are adding an energy level. And what happens to your size when you add an energy level? Well, it's obviously getting bigger and bigger. So as you go down a family or down a column, your size increases. What happens when you are going across a period is actually kind of interesting because everybody thinks, well, your mass gets bigger, so therefore your size is getting bigger. No, your mass gets bigger, but actually your size gets smaller, meaning you're actually becoming more dense. And the reason why is because back to the trend, what happens is that you've got your electrons, okay, and they are once again influenced by their attraction to the nucleus. The ones that are only, let's say, attracted somewhat, like those weak magnets, the Malin magnets, is because they have a lower proton count or lower nuclear charge than those that have, let's say, a cow magnet or the +8 magnet. These have a very strong nuclear charge. So the electrons are a lot more attracted to that one with 8 protons than the electron that has only 1 proton. So because this guy is so much more attracted to the nucleus, it's going to be want to come closer and closer and closer to it. So what happens to the size is that it actually gets smaller and smaller and smaller. So here's the trend of the atomic radius going down a family. As you see, you're adding energy levels, so your size increases. And as you go across a period, what happens is that the nuclear charge increases, so the electrons become more and more attracted to the nucleus, so therefore they get smaller and smaller. So you are going to have to identify the easiest way to do the periodic trends is to identify the very largest atom and for each of these trends and then base everything off of that. So if you are decreasing as you go from left to right, you're going to be increasing when you go right to left. If you increase going down the family, what's going to happen is that francium is the largest. So how I tell my students to remember is AR is the large for atomic radius is FR. So francium has the largest atomic radius. ARFR, ARFR, ARFR. All right, so looking at a graph, what you can notice is that if we compare the atomic radius to the atomic number, as you're going, we're going to focus on this is period 3. As you're going across a period, what do you notice? It goes down, okay? But these are the ones at the top are the ones that are going down a family. And as you notice, what happens as you go down a family or down a column is that trend goes up. All right, this is on the atomic radius. Remember, AR equals FR as far as the largest one goes.